Today, we're talking about a component that is so often overlooked, yet absolutely critical to an automatic vehicle's powertrain. We're looking at what I like to call the silent assassin of the drivetrain, the automatic transmission flex plate. Because listen, when this single component fails, it can literally take the entire drivetrain down with it. So we're going to set the stage for a professional-level deep dive into diagnosing, inspecting, and replacing the flex plate to make sure your repairs are absolutely flawless.
Here is our roadmap for this explainer. We'll start with the anatomy of the flex plate, differentiate those complex drivetrain noises, dig into the root causes of metal fatigue, walk through a professional teardown inspection, cover flawless reassembly and alignment, and finally, we'll talk about how to translate these risks to your customers.
So, kicking things off with Section 1, Anatomy of the Flex Plate. Because to accurately diagnose a complex failure in the bay, we first have to understand the component's baseline specs and exactly what it was engineered to do.
Honestly, it's pretty incredible when you think about it. This tiny, thin piece of high-strength stamped steel is solely responsible for power transfer from the engine to the transmission. Depending on the vehicle model, they're usually made from specific high-tensile steel grades like SAE 1045 or ASTM A1011. And get this, they're usually just 2 to 6 millimeters thick. It features a welded or integrated ring gear with anywhere from 100 to over 160 teeth for the starter motor to grab onto. But its real genius is right there in the name. It's designed with controlled flexibility. You can think of it like a giant rotational shock absorber. It spins the torque converter, while simultaneously flexing to absorb minor crankshaft flutter and torsional vibration.
Now, there's a crucial distinction we have to make here, because these two are absolutely not interchangeable. A flex plate, which is used exclusively in automatics, absorbs and flexes. A manual transmission's flywheel, on the other hand, is a big, heavy, thick piece of cast iron that rigidly resists vibration to provide a clamping surface for the clutch. So the analogy to remember is this. A flex plate yields to protect the drivetrain, while a flywheel rigidly resists. And if a flex plate becomes too rigid, it cracks.
Moving right along to Section 2, Differentiating Complex Drivetrain Noises. This is where we get into the most critical part of our diagnostic workflow, isolating those specific audio symptoms so we can tackle the most common failure points first. Building a foolproof mental cheat sheet for differentiating noises is absolutely key. When you're listening to a vehicle, a bad flex plate gives off this rhythmic, metallic knock that follows engine RPM, and you'll hear it right there while sitting in park or neutral. Sometimes it might even completely disappear at higher RPMs because of centrifugal loading. Compare that to a torque converter issue. That's load-dependent and feels way more like a shudder, or an internal transmission noise, which is going to change based on vehicle speed and specific gears. Establishing this workflow prioritizes your common failure points right out of the gate.
So here's a massive point. A clicking noise or whining during startup is so frequently misdiagnosed as a bad starter motor. Techs will just throw a brand new starter at it, only to have the exact same problem pop up a week later. Why? Because the starter is actually engaging in uneven or damaged ring gear on the flex plate. You might also notice the starter completely bogging down because the bent plate causes it to bind up. Or you might feel a heavy vibration coming right up through the floorboards the second you shift from park into drive or reverse.
All right, Section 3, Root Causes of Metal Fatigue. Now that we know what we're listening for, we really need to shift our focus from what is happening to why this high-strength metal is fatiguing over hundreds of thousands of cycles. Like we talked about earlier, excessive rigidity causes cracking, and excessive flexibility causes fatigue. And as you can see, almost all of these root causes stem from alignment or installation errors. If your crankshaft end play is out of spec, or if that bell housing is misaligned, the flex plate is essentially being forced to bend further than its design allows on every single rotation. Heck, even a bad engine misfire can create enough torsional shock over time to fracture that stamped steel. I really need to reiterate this because this is the golden rule of this explainer. The bad flex plate is usually the victim, not the original crime. It is almost always a secondary symptom of a malfunctioning transmission, improper torque, or a poorly aligned torque converter from a previous repair.
Section 4, the Professional Teardown Inspection. Once your acoustic diagnosis points straight to the flex plate, it's teardown time. And please, before you pull that transmission, ensure you are following all of your shop's safety protocols for securely supporting a vehicle and transmission on the lift.
Now, during your visual inspection, what you really want to hunt for are these specific stress fractures. These cracks are sneaky. They're often completely invisible until the transmission is fully removed and the inspection cover is out of the way.
Pay incredibly close attention to the metal right around the crankshaft bolt holes and those torque converter pads. Keep an eye out for heat discoloration too. That's a dead giveaway of movement and unwanted friction. And of course, carefully inspect the entire circumference of the ring gear for any chewed-up teeth.
You can't just replace the cracked plate and call it a day. You have to follow these steps to make sure you aren't leaving the root cause sitting right there in the bay. Check the torque converter for any imbalance. Inspect your transmission mounts, because a sagging mount completely ruins your alignment. And critically, evaluate your starter motor gear and its alignment, because if that flex plate wobble overloaded the starter drive, leaving that damaged starter in there will absolutely destroy your brand new flex plate's ring gear the second they turn the key.
Next up, Section 5, Flawless Reassembly and Alignment. This brings us to the professional protocols required to put it all back together, so we can completely eliminate that dreaded comeback repair.
Okay, let's dive into this pro-level sequence. Step 1, verifying your crankshaft end play is an absolute must before that new plate ever goes on. Step 2, never ever reuse stretched bolts. Always use new flex plate bolts and hit them with thread locker. Step 3, torque them down to the manufacturer's exact specification, which is usually around 35 to 55 foot-pounds, and always use a star pattern sequence to avoid warping your brand new plate. Finally, confirm that the torque converter is fully seated into the transmission pump before mating it to the engine, and double-check your starter alignment. Guys, these steps are absolutely non-negotiable.
Taking the extra 10 minutes to do it by the book is everything. Slapping it all back together with an impact wrench without verifying your alignment or using a proper torque wrench practically guarantees you're going to be doing this massive, heavy, labor-intensive job twice. Do it right, do it once. Finally, Section 6, Translating Risks to Customers. For our last section, we need to equip our service advisors and techs with the clear, direct scripts they need to communicate these technical realities to non-mechanical vehicle owners. When you're explaining this to a customer who is maybe a little hesitant to authorize a massive transmission drop just for a clicking sound, use this exact translation. It conveys the severe safety hazard perfectly. Explain that a flex plate directly connects the engine's power to the wheels. If that plate breaks apart while they're driving at highway speeds, it causes a sudden, total loss of power delivery. That is an incredibly dangerous situation for any driver to be in.
The crucial point you have to communicate is that continued driving will multiply their repair costs astronomically. It goes from replacing a single, relatively inexpensive stamped steel plate to a catastrophic drivetrain failure. We're talking about ruining the torque converter hub, destroying the transmission pump, or even causing permanent, unfixable damage to the engine's actual crankshaft flange.
I'll leave you with this final provocative thought for the next time you're diagnosing a drivetrain in the bay. When you pull out a shattered, heat-discolored flex plate, ask yourself, are you truly fixing the root alignment and installation issue that caused it in the first place, or are you just setting a timer for the exact same failure?